Hello everyone, I'm Russ LeBlanc, your NEC consultant and code expert. Thank you for joining me. In this video, I'm going to be explaining branch circuit calculations for motor outlets. Specifically, we're going to be looking at section 220.14c. So if you want to grab your 2023 codebook and a pen or a pencil and some paper and maybe a calculator, we can dive into these calculations. Okay, again, the focus is 220.14c, branch circuit calculations for motor outlets. In that section, it says the conductor sizing requirements in 430.22, 430.24, and 440.6, which is for air conditioning and hermetic refrigerant motor compressors. Those sections are used to calculate the loads for motor outlets. So essentially what we're going to do is we're going to perform the load calculation as if we were sizing wires for these motors and these motor operated appliances and these air conditioners. That's what we're going to do, as if we were sizing conductors. That's how we perform the load calculations. So if we're sizing wires for one motor, we need to look at 430.22 because that's how we're going to treat the load calculation. In that section, it says, conductor supplying one motor used in a continuous duty application shall have an opacity not less than 125% of the motor full load current as determined by 430.6A1. Now, generally speaking, any motor application is considered a continuous duty motor application unless the apparatus does not allow the motor to operate continuously with load under any conditions of use. And this is not just a rule of thumb. There's actually a couple code sections. One is table 430.22e and section 430.33. Both those sections basically say that every motor is a continuous duty application unless you're specifically told otherwise. So that's a pretty safe assumption, right? So it's not just a thumb rule. It's actually some code rules. And so we're just going to assume that it's a continuous duty application. All right, and so we have to, again, look at 430.6A1. If we were sizing conductors, that's what we would do. And so there it says, generally speaking, and I have to say it that way, generally speaking, because one of the things about Article 430 is it seems like for every general rule, there's like 5, 6, or 7 exceptions. So we're going to ignore most of the exceptions. So I'm going to say it that way. Generally speaking, we're going to use the full load current ratings from the codebook tables, including table 430.247, 430.248, 249, and 250. We're going to use those full load current ratings instead of the current rating or the full load amperage marked on the motor nameplate. Now, there is one exception we are going to look at because it's a super important exception that I think you'll be able to use pretty much all the time. So we'll get to that in a second, though, all right? But we're going to ignore the other exceptions for now. All right, so there's a good example of a motor. It's not part of an appliance, right? It's just a motor all by itself, and the branch circuit wiring is supplying it, and it's connected to a controller just to the right of the motor. It's just above me on the screen. You can see that gray box here. There's a motor controller, and you see the flex has the branch circuit wiring going to it. So how do we calculate the load for this, right? That's what we're going to do. As if we were sizing wires, that's how we calculate the load. So basically it comes down to this. The branch circuit load is equal to the table full load current for this motor, not the nameplate amperage, the table full load current times 125%. That's what we would do if we were sizing conductors, right? So that's how we're going to calculate the load. So for example, if I tell you this is a 1 horsepower, 115 volt motor, single phase motor, we would have to look this motor up in table 430.248, all right? That's the table for single phase AC motors. So if we take a look at that table, right, and this is obviously my version of the table, we have to find that 1 horsepower motor at 115 volts. And that 115 volts is the nameplate rating. That's not a system voltage, right? So there it is, 16 amp. That's the number we use to calculate the branch circuit load. All right, that's 16 amps. And so, again, we're going to take that table current, 16 amps, and multiply it by 125%. And there's that math, right? The 16 amp from the table 43248 times 125%, 20 amps. That's the calculated load for this motor outlet. Now keep that 1 horsepower motor in mind, right? This was 16 amps based on the code book tables. Now there's an important exception I do want to look at. Specifically 430.6A1 exception 3, right? Because there's going to be times when we're dealing with motor operated appliances, right? Not just a motor like I just showed you, right? It's not part of an appliance, but you might be calculating the load for a garbage disposal or a central vacuum system, right? So those are not just motors, but they're motor operated appliances, right? So exception 3 is super important in this case. Here's what exception 3 says. For a listed motor operated appliance, like a disposal, like a central vac, things like that, if it's marked with both horsepower and FLA, full load amps, the full load amps, the FLA marked on the nameplate of the appliance shall be used. The nameplate shall be used. The amperage on the nameplate shall be used instead of the full load current ratings from the code book tables. That's pretty cool, right? There's a couple qualifiers here we want to mention here, right? 422.6 basically is going to require appliances to be listed, right? So most of the appliances in a house, for example, unless they're low voltage, right, which could happen, but a disposal is going to be 120 volts. A central vac is going to be 120 volts. Most of these are going to be 120 volts, 240 volts, things like that, right? So 422.6 says all appliances on circuits 50 volts or higher, they're required to be listed. So you shouldn't encounter an unlisted garbage disposal, an unlisted central vacuum. If you did, it'd actually be a code violation to install it. All right, so we'll just pretend there's no such thing as a code violation. Okay, here's a nameplate for a garbage disposal, right? And it is listed, it's required to be listed, and exception 3 says if it's listed and it's marked in both horsepower and amperage, well, then we can use the amperage on the nameplate instead of going to the code book tables. All right, and there it is, right? It has both amperage and horsepower, and so we can use that, right? The 10.2 versus the 16 from that first motor I showed you, that was also a 1 horsepower motor, but in that case we had to go to the code book tables, and it said 16 amps. That's a big difference, right? 10.2 amps versus 16 amps. That's a huge difference there. So the math is still the amperage, in this case, the FLA times 125% instead of the table current times 125%. So the math for this garbage disposal looks like this. 10.2 amps times 125%, that's 12.75 amps. That's way different than 20. 20 amps was the first motor I showed you, right, where we had to use the table value. Here we can use, actually we're required to use, right? It's not even an option. You have to use the nameplate amperage in this case. Okay, now when we get to more than one motor, right? So there's 2 motors, 3 motors, 4 motors, or it's a motor plus some other loads. We have to look at 430.24 for that. We have to sum all these items together. The first thing is we have to take the largest motor, full load current, at 125%. And again, that's based on current, right? Not horsepower, not VA. The motor current is taken at 125%. And then we add to that the sum of the full load current ratings of all the other motors in that group. And then we add 100% of any non-continuous, non-motor loads. And then we take any continuous loads that are non-motor loads and we multiply those at 125% and we add those into this calculation. All right, so here's 3 motors, right? One of them is the largest motor, or the highest rated motor, I should say. And so the branch circuit load is equal to the highest motor full load current rating, and we'll say that that's the one highlighted in yellow you see there, plus the other two motor full load currents, just at 100%, right? So the one highest at 125%, and then all the other motors at 100%. We add those together, and that's the calculated load for this group of motors. Now we have a motor or motors and some other non-motor loads. So the branch circuit load equals the highest motor full load current times 125%, and we'll say that's the motor that's highlighted in yellow there, plus the other motor full load current, and that's the motor highlighted in blue on the screen, plus the other non-motor loads, and highlighted in red up there we have an industrial battery charger, just as an example of another non-motor load. And then the last thing is we take the continuous loads at 125%, and you see that light fixture up there highlighted in green, and that could be an example of a continuous load. We would take that at 125%. We add all those things together, and that's our calculated load for that particular branch circuit. Okay, here's another example where we have on the top, that's a disposal, and then the bottom is a dishwasher, and we want to put these on the same branch circuit and calculate the load. Okay, taking a look at the top, right, 6.3 amps, and it has both amperage and horsepower, so we're actually, and it's listed, so we're required to use that 6.3 amps. And I'm going to be honest with you, the horsepower rating that you see on some of these appliances, not always accurate, right? I have a shop vac, for example, right? And it's a 120 volt shop vac, and there's a big label on it. It says 5 horsepower. I don't think so. If you looked up a 5 horsepower motor at 120 volts in table 43248, I think it draws like 56 amps according to that table. But the nameplate on my shop vac says 10 amps. So it's obviously not really a 5 horsepower motor. It's more like a half horsepower motor, maybe 1 horsepower motor top. So, but manufacturers can kind of pump that horsepower up just as a marketing gimmick, if you will, right? Which would you rather have? A shop vac that's 3 horsepower or a shop vac that's a half horsepower, right? So that's, not really enforced, honestly, that horsepower rating when it comes to appliances. But the amperage is accurate. And so if it's listed, you have to use the amperage on the appliance instead of the horsepower rating, and then go into the code book tables, right? And so that's why we use the amperage instead of the horsepower, because the horsepower is kind of almost a made-up number on some of these appliances. On the bottom nameplate there, that's a dishwasher, and you see the amperage there is 9.6 highlighted in red there. So we have to add these two together, right? So the disposal, because it's a motor, and it's the only motor of the group, we take that at 125%. So 6.3 times 125%. The calculated load for the disposal is really like sizing wire. We would use 7.875 amps. And then we add the dishwasher to that. That's 9.6 amps. We add those two together. So the calculated load for these two items on this branch circuit is 17.475 amps. And then we can take that information and go to Article 210 and apply a whole bunch of requirements there as far as sizing conductors and overcurrent protection and how much load is permitted per outlet, et cetera, right? This is just a calculated load from Article 220. And obviously we can tie in all kinds of other code rules with this load calculation. Okay, when it comes to hermetic refrigerant motor compressors and air conditioning, we're supposed to look at 440.6. All right, if we go there, 440.6a talks about hermetic refrigerant motor compressors, like the one you see on the screen there, where it's kind of all by itself. It's not really part of an appliance, for example. It's all by itself. So if we are running a branch circuit to this, we're supposed to use what's called the rated load amperage instead of FLA, like a motor. Compressors use RLA, or rated load amperage. So we have to find the nameplate on the compressor and use that for the load calculation. All right, so there's an example of the compressor nameplate, and we're looking for the RLA, and there it is, 6.6 amps. That's the number we use for load calculations. Don't use the LRA, 46 amps there, you see that? That's the locked rotor amperage. We would use that for sizing disconnects as far as figuring out the equivalent horsepower. I'll probably do a video on that at some point too, so watch for that video. Equivalent horsepower calculations. Okay, when it comes to multi-motor equipment, we're supposed to follow whatever 440.6b says. All right, so here's a nameplate for an air conditioning unit, and you can see the blue and green arrow there. There are two motors. Well, one's a compressor motor, a hermetic refrigerant motor compressor, and then the other is a fan motor, right, the evaporator fan. So there's two motors, or a compressor and a motor. Now 440.6b says we're supposed to use the compressor RLA and the motor FLA marked on the equipment nameplate. We're supposed to use that for load calculations. All right, so there's the blue arrow showing you the 16.1 amps for the compressor RLA. We're supposed to use that. And we add that to the motor FLA of 1.4 amps. That's what we're supposed to do, right? But keep in mind, because there's multiple motors, we're supposed to take the highest rated compressor or motor at 125%. Okay, so we could do that. In this case, it would be the compressor, right? The compressor is higher. We would take that at 125%, and we would add the FLA of the other motor to that. That's our branch circuit load. I'm going to show you a cool trick, though, right? And I'll be honest with you, I don't know why we're not sent or referenced to 430.25 and 440.35 when it comes to multi-motor equipment, right? Because those sections say when you're sizing conductors, you're supposed to use the minimum circuit ampacity marked on the nameplate. And so there you see it. The MCA, or the minimum circuit ampacity, is 21.5 amps, and that's what we're supposed to use for sizing wires. Right? We can use that. Absolutely can use that. And we can use that because the manufacturer has already calculated the load using the highest rated compressor or motor at 125%. Cool. They've done the math for us, so we can use the 21.5. And I can show you that, right? If we do the math, there it is. Right? The compressor at 125% plus the motor, 21.5 amps. So you can just use that instead of doing the math yourself. Thank you very much. Okay, that's it for that video. Stay tuned for more. We have all kinds of other videos for load calculations. See you on the next video.